Good morning, everyone, and welcome to today's lecture. We are going to start with your what next chapter, which is work, power, and energy. This chapter is somewhat simpler as compared to the previous one, and the applications of this chapter we are going to find in many topics which are coming, because this work, power, energy will be coming everywhere. Almost in each and every topic, we will have this work, power, and energy coming. So it consists of three different headings: work, power, and energy. And we will deal with them accordingly. The first one in line is work. So everyone knows what is work. Tell me what is work. Work. Yes. Tell me what is work. Hmm? No one knows what is work? You haven't
Forcing
heard about the
displacement.
term work, beta?
Forcing displacement is
Force into displacement is work. Okay. Anything else? What type of quantity is work? What type of quantity is work?
scalar.
It is a scalar quantity. Work done is a scalar quantity. And if you are saying it is force into displacement, what type of quantity is force?
Said to be work.
Yes, beta?
When a force displaces an object is said to be work.
When a force displaces an object, work is said to be done. That is probably more appropriate way of saying it. Now, whenever we talk about this letter or this word work in our everyday life, it has a slightly different meaning when we talk about the same work in physics. Why it is different? Right now, if I talk about my everyday life, I'm taking a class, I am doing work. You are in the classroom attending the class, you are also doing work, mental work, physical work. Everyone is doing work right now sitting in the class. But when I talk about work done in physics, it is somewhat different than the work that we are doing now. So the way we use the term work in day-to-day life and the way we are going to do it here is somewhat different. How it is different? Right now, according to physics, we are not doing any work. We are just sitting idle and not doing any work. Because work in physics is defined in a slightly different way compared to work in our day-to-day life. Right now, I'm doing work, but in physics, I'm not doing any work because work done in physics is somewhat different. How do I define the work done in physics? How do I define work done in physics? So, whenever you apply a force and you produce a displacement of the body, now it also depends on in which direction that displacement is produced. So, if I say very correctly, work is said to be done in physics by a force when the force produces a displacement in the body. So, displacement has to be there on which it acts in any direction except perpendicular to the direction of force, because if the work is done by a force in a direction which is perpendicular to the force, it is not considered as work done in physics. Do we understand this? Everyone understands this? I can't see you. Don't know what's happening in the class. Everyone understands this? This is how work done is defined in physics. There must be force, there must be a displacement, and the displacement must not be at 90 degrees. If the displacement is at 90 degrees, then according to physics, no work is done. That means if a porter or a coolie is lifting your heavy luggage, in physics, we know that in normal day-to-day life, he is doing a lot of work, but in physics, that work is actually zero that is done by him. So the way we use work in everyday life and the way we use work in physics is different. So two conditions must be met for anything to be called as work in physics. There must be a force, there must be a displacement, and the angle between force and displacement must not be 90 degrees. That is how work is defined. Now, if I write it in terms of an equation, how do I write this work in terms of an equation? So I will use dW. Small amount of work done is F dot ds. It is the dot product of force with displacement. That means if there is a force F, which is a vector, it displaces some body by a small displacement delta S or delta R. Let me not write delta S. Let me write it as delta R because R we are using for displacement. Delta R. Then the work done by this force is F dot delta R, or you can write it as F magnitude of F into dr into cos theta. Well, what is this cos theta? What is this cos theta? This theta is the angle between the vector of force and the vector of displacement. That is how work done is defined in physics. Now, this is the small work. If I want to find out the total work, I will always write work. I will always write work as delta W. I don't know why. Delta W, work done by any force will be F dot dr ka integral. Or you can write it as integral of F into dr into cos of theta, where theta is the angle between force and displacement. I hope up till here things are clear. Yes or no? Okay. I hope everyone is noting this down. This is how we start, and this, if you understand the concept of this work, things are going to turn out very nicely because we will be using this a lot throughout our course. Now, if your force is constant, if the force F is constant, if force F is constant and at the same time theta is same at all places, the angle that it makes with the displacement of the particle is same at all places, then I can write this work done as, work done by this force can be written as F dot your displacement, or it can be written as F magnitude into delta R into cos theta, where theta is the angle between force and displacement. We have already seen that, and that angle has to remain constant. If it's not constant, then this formula is not valid. Force into displacement magnitude wise multiplied by cos theta. Now, what type of quantity is force? Now, this force is a scalar quantity. This force is a scalar quantity. The SI unit of this force is Newton meter, or you can call it joule. Joule is used for energy. Joule is also used for work. I mean, energy and work are related to each other, and that is why the name of this chapter is work, power, and energy. The dimension, and you must remember the dimension of work. You cannot forget it at any point in time. The dimension of work is ml square t minus 2. Work done is a scalar quantity. Work done is a scalar quantity. Since it is a scalar quantity, it can be positive, it can be negative, or it can also be zero. What decides whether the work done is positive, negative, or zero? Yes, work done by a body can be taken as positive or negative, or it can also be zero. Even if there is force, even if there is displacement, the work done by the force can be positive and negative, or it can also be zero. Who is going to decide whether the work done is positive or negative or zero? What decides it? Yes.
Displacement, sir.
How does displacement decide? How does displacement decide whether the work done is positive or negative? Just tell me. How does displacement decide? If displacement decides, how does it decide? You may be correct. You must believe in yourself. If you think that you are correct, you must believe in yourself. If you can't explain, that means you are not sure about yourself. Yes, anyone could tell me when can work done be positive? When is work done negative? Who decides it?
When the direction of applied force and the displacement is on same, then the work done will be positive, sir.
So how does displacement decide that? You said displacement decides it. How does displacement come here? Displacement does not decide whether the work done is positive or negative. It is the force which is applied. This also not does not decide. There is a factor there. If you look closely enough, you will see that factor that decides whether the work done by the force is positive or negative. What is that factor? If I look at this formula, there is this cos theta here. Because force and displacement, magnitude are used, so they cannot decide whether the work done is positive or negative. Look at the formula. Work done, positive or negative or zero, decided by the angle. Decided by the angle. How does it decide? If theta is acute, and the angle between force and displacement is acute, then cos theta would be positive and work done would be positive. If this theta is obtuse, work done by this force will be negative. If this theta is 90 degrees, that means force is perpendicular to the displacement. This work done is zero. Therefore, in the definition, it was said that the angle between force and displacement should not be 90, because if it is 90, work done is zero. So basically the angle decides between the force and the displacement. What is the angle? That angle decides whether the work done is positive or negative. If this is my force F, which is applied on the body, and my displacement is anywhere in the first quadrant, or my displacement is anywhere in the fourth quadrant, the angle between force and displacement would be acute. And in this condition, my work done everywhere in this blue zone, the first and the third quadrant, everywhere, the work done by this force would be positive because the angle is acute. Whereas if my displacement is like this, or my displacement is like this, my force is here, remember. If my displacement lies in the second and the third quadrant, this green zone, my displacement is in the green zone, angle is obtuse, and my work done by this force will be called as negative. Positive in the blue zone, negative in the green zone. When it is going to be 0, if my displacement is perpendicular like this or like this, in these two cases, my work done would be 0 because the angle between force and displacement is going to be 0. So this diagram and the angle decides whether the work done by the force is positive, negative or 0. Remember, it's not the force or the displacement that decides. It is the angle between the force and the displacement that decides whether the work done by the force is positive or negative. Do we understand this? Please note it down because we will be encountering this positive and negative work throughout our discussion on throughout your 11th standard as well as 12th standard. Work done, work done, work done. Will be coming almost everywhere in every topic. Have you noted it down? Okay, good. Let us move forward and let us again see it in a different way. Same thing, just drawn in terms of a block kept on a surface, and you can see in one case the angle is acute, in one case the angle is obtuse, and you have for the acute angle work done being positive, for the obtuse angle the work done being a negative. This is how we decide whether the work done by a force is positive or negative. Remember this concept because a positive work is a positive work and a negative work is a negative work. Positive and negative tells us a lot of things whether force and displacement are at an acute angle or are at an absolute angle. That makes a lot of a difference. You cannot call negative work as positive work. You cannot call positive work as negative work. You cannot tell what is the magnitude of work. No, positive and negative make a sense here. Have you noted this down? Shall we move ahead? Okay. Again, these are some examples. You don't have to draw the diagram. This is just to make you understand. Work done. If someone is lifting a weight, work done by him is positive. But work done by gravity is downwards.
Sir, we
And,
have not yet written.
and displacement is upward. So work done by gravity would be negative, but work done by the man would be positive. If you are moving along, your force and displacement are at an acute angle. Work done is positive. Work done by friction, because friction is going to be in the opposite direction. Work done by friction is going to be negative. So it just depends on the angle between the force and the displacement. The angle is acute. Work done is positive. If the angle is obtuse, work done is going to be negative. You don't have to draw the examples, just to make you understand when is work done positive and when is work done negative. Again, remember, every kid of third standard can note what is there on the whiteboard. You are not a copying machine. You are not a Xerox machine. You are students. You are living beings. You are not Xerox machines. Do not Xerox everything that is there. Understand what you mean and just write it in your language. You are not Xerox machines. Let you Xerox everything that is on the board. You have to understand what is being said and just write it in the language that you understand. What I feel, what I see always is students behave like Xerox machines. Note down everything. And when you ask, no one knows anything. But sir, I have notes. That doesn't help unless you write the note in the language that you understand. I am writing it in the language that I understand. And I think that everyone will understand in the same language. That is not true. If you've understood something, which I have tried to explain, I may not have written it. I have tried to explain, understand it, and write it in the language. Okay, I hope you have done. Yes or no? Then another example of work done being positive and negative. Why I'm insisting so much on positive and negative work? Because it might create confusion later on. So it is better if you understand the concept now only. Whatever doubts are there will get cleared. Again, if you are stretching a spring force is like this. You are stretching it here. You are applying a force in the same direction. Your work done would be positive. Work done by spring would be negative. Then you have repulsion between two charges. They are repelling each other. If they are moving towards each other, work done would be negative. So basically, force and displacement are in the same direction. Work done is positive. Acute angle, work done is positive. Opposite direction, obtuse angle, work done is negative. Work done can be maximum or minimum as well. If the angle is 0, work done will be maximum. If the angle is 180 degrees, you can call work done as minimum, but it's actually not minimum, because negative sign does not tell you whether it's maximum or minimum. Wrong word is used here. Mm,
Sir, we have not yet written, sir, previous page.
Don't have to write the previous page. You just have to understand it. The diagram you don't need to write. Are you drawing the diagram and writing? No need for that. There's no need for that. If you want to write, you can write it. Again, try to understand what I am saying. You are behaving like a Xerox machine. You are not Xerox machines. Don't have to write everything, every word that is on the board. I'm just trying to give you examples to make you understand which is positive work and what is negative work. That's it. Don't have to draw the man doing that like this. This is of no use. Try and understand data. Don't try to write everything. Okay, let me know once you are done.
Sir, completed.
Completed? Congratulations then. Okay, then as I was trying to explain, if the angle between force and displacement is 0, work done would be maximum. If the angle between force and displacement is 180 degrees, they have written minimum. It is not minimum actually. Positive and negative does not mean maximum and minimum here. Positive and negative just means you have to understand the angle. 10 joules of work in the positive direction and 10 joules of work in the negative direction are actually same. Positive direction means force was in the same direction or acute angle. Negative means force was in the opposite direction or obtuse angle. So it's not maximum and minimum in that sense. They are both equal. 10 joules of work you do in any direction, it is equal, whether it is in this or this or this. Doesn't matter. Positive and negative only tells us how was the force and how was the displacement, what was the angle between force and displacement. That is the only thing that we understand with positive and negative work. Have we understood this? Have you noted this down? Yes or no? Note it down and let me know once you are done. Remember, again I keep on telling you, writing every single word of what I say is not important. Important point is that you understand what is being taught and then you write it in your language. That is the best notes that you can ever make. Let me know once you are done.
Done, sir.
Done, sir.
Okay, then we come to the examples of zero work. When will work done be zero? As you can see, work done is F into S into cos theta. The first way it can be zero is by force being perpendicular to displacement. As I given you the example of this coolie. This coolie is moving on a flat ground. The angle between the gravitational force, the weight of the mass that he is carrying is downwards and he is moving along the horizontal. Physics says he does not do any work, but we know that he does a lot of work. So if the angle is 90, work done is zero. If the displacement is zero, if I am trying to push this wall and this wall is not moving, that doesn't mean that I'm not doing any work. I'm doing work, but that is not recorded as work in physics because displacement is zero. Third case, if there is no force acting on the body, the work done would definitely be zero. If there is no force, there is no work done. That means if I'm not applying any force, if I'm talking and I'm not applying any force, I'm not doing any work, but God knows that I'm doing a lot of work teaching you guys. So three ways work done can be zero, angle 90, displacement 0, force 0. Don't have to write the examples. If you want, you can write it just for making you understand why it is there, why this work done is 0. This formula we will come across in your 11th standard, in your 12th standard. You don't have to worry about it right now. Just understand when is work done 0. I'll give you 2 minutes to note it down.
Done, sir.
Anyone has noted this? Okay, let me know once you're done.
Done, sir.
Okay. Now, sometimes what is going to happen is more than one force is acting on a body. More than one force is going to act on the body. We'll be encountering questions where not one but more than one force will be acting on a body. Now, if more than one forces are acting on a body, the network done will be summation of Wi. You understand the meaning of what is written here? You understand the meaning of what is written here? It will be work done by force number 1 plus work done by force number 2 plus and so on. If a number of forces are acting on a body, total work or network is the addition of individual work. Do we understand this? Okay. Note this down.
I completed.
Good. Okay, then comes this question. You have a 5 kg block that is moved on a smooth floor by a 10 Newton force for a distance of 2 meters. What are the forces working on this body? How many forces are working on this body? Yes. How many forces are working on this body? It's a simple question. Without any hidden agenda. How many forces are working on this body, beta?
One.
Anyone else with a different answer?
4.
4. What are the 4 forces?
Normal force, gravitational force, applied force, frictional force.
I did not say that there is a Did I say that there is a friction here? I did not say there is friction here. So there are three forces here working. There's no friction. This is smooth. So you have to find out the work done by all the forces. Work done by the 10 Newton force. You have to find the work done by gravity. We have to find the work done by normal reaction. And you have 2 minutes to do this. Okay. No one got any answer for the simple question?
Star delta WG delta WN is equals to 0.
Yes, both of these are 0. Why it is 0?
Perpendicular.
Why it is 0?
Angle is 90.
Angle is 90. The normal reaction is acting upwards and the displacement is here. So the angle is 90. Gravity is downwards. Work done is 90. The only work done is work done by the 10 Newton force. And what is the work done by the 10 Newton force? What is the work done by the 10 Newton force? Yes. No one knows the work done by 10 Newton force?
Minus 20.
How did you get minus?
20.
So work done by this 10 Newton force. I thought that you will understand everyone. I did not think that I will have to do this question for you. Anyways, work done by this 10 Newton force. Force is 10 multiplied by displacement is 2 meters. Multiplied by what is the angle between force and displacement? This is force. And
0
this is
degree.
displacement. What is the angle?
0 degree.
Cos of 0 is how much? 1. So the answer is plus 20 joules. Was it such a difficult question to do? Not good, not good. I'm not impressed. I'm really not impressed with your theatrics in this question. Really not impressed. This is such a simple question. Not good, not good. This is definitely not good. Anyways, I will try another one, and I hope that I am not disappointed this time around. I have a 3 kg block. And I have a force of 10 Newton at an angle of 37 degrees. And I again displace this block by, let us say, 5 meters. Take a deep breath. Open your eyes. Solve the question. Get the answer. Stay happy. 2 minutes you have. Everyone should solve it and give me the answer.
Sir, 40 newtons.
40 Newton by which force? You have to find the work done by all the forces. So how do you do this? You draw the free body diagram. Wrong color. Weight is 30 newtons. Normal reaction is 30 newtons.
100/3, sir.
What will be the work done by normal reaction? Is 0. Work done by gravity is 0. The only thing that is left is work done by the 10 Newton force. Force is 10 multiplied by displacement is 5 multiplied by the angle between force and displacement. What is the angle here? What is the angle between force and displacement?
37.
37 into cos of 37. What is cos of 37?
4/5.
4 by 5. That is your answer. 40 Newton. No, 40 joules. That is the answer. Do we understand this? How many of you got this answer? Not many. I'm surprised. Anyways, please note this down. Meanwhile, I'll give you one more question. Everyone noted this down? Have you understood what problem we were facing and what we were doing right and what we were doing wrong? Okay, so this is the question. Now we have friction coming into the picture. A block is at rest. I apply a force of 10 newtons. Find out the work done by all forces in 5 seconds, and you have 2 minutes to do it.
All will be 0, sir.
All 0. Why? What is the reason?
The object is in rest, sir.
Will it not move? So I'll give you this question as homework. Remember, we are doing physics, beta. We might be done with Newton laws of motion, but that does not mean that Newton laws of motion are not going to come in the next chapter. This is the problem with physics, which is not the problem with chemistry or maths. Maths also has the same problem. Because if you have done quadratic equation once, that does not mean that you cannot find quadratic equation in another chapter. Chemistry, this problem does not come. If you do not understand P block, now we are into S block. Forget about the P1. Nothing of P will come into S. Nothing of chemical equilibrium will come into nuclear chemistry. Hey, equilibrium gone. Redox reaction gone. If I don't understand redox reaction, hell with it. The next chapter is hydrogen. Nothing to do with redox reaction. That's now not how physics works. Physics works on logic. And if you don't understand the previous topic, the next topic we'll just dance and do nothing. So remember this, everything is related to each other. There are very few topics in physics which are standalone. That has got nothing to do, very less to do with the past and very less to do with the future. There are very, very few topics. I can count them on fingers. There are only 2 or 3. So solve this question at home. This is a simple question. And we have done 50, 100,000 times more difficult question than this one. And if you can't do this one, that means that 50,000 times question is no longer possible. Please pull up your socks. I feel that you guys are getting a bit loose. That is not good. That is definitely not the need of the hour. So think about this question, solve it, give me the answer in the next class. This is as simple as question. In fact, this is the first question of friction. Okay, so do it, and we will discuss this question in the next class. Remember, this chapter is a continuation of what we were doing in the previous chapter. It is not okay. Previous chapter khatam, but that new chapter finish. Then everything new. No, it's just a continuation of what we are doing, and this will continue until we finish your 11th standard. And in your 12th standard, again the same things will come. So please remember that. Okay, so I'll see you in the next class. Take care. Solve this question, and I need an answer from everyone. Bye bye, everyone.
Thank you, sir.
Thank you, sir. Thank you, sir.